Let us solve some prove the following types problems. The first one is sec theta into bracket 1 minus sin theta into sec theta plus tan theta is equal to 1. Let's take left hand side first and simplify. We get sec theta minus sec theta into sin theta into sec theta plus tan theta. What we have done? We have multiplied by sec theta into this bracket. Sec theta into 1, sec theta minus sec theta into sin theta. Second term, sec theta plus tan theta, we have kept as it is. We already know sec theta is equal to 1 upon cos theta. So let's replace the second sec theta by 1 upon cos theta. What we get? Sec theta minus 1 upon cos theta into sin theta as it is. Into bracket, sec theta plus tan theta remains as it is. What is sin theta upon cos theta? It's tan theta. Do you find sin theta upon cos theta here? Let's replace it with tan theta. What we get? Sec theta minus tan theta into bracket sec theta plus tan theta. Now we can use a plus b into bracket a minus b is equal to a square minus b square. Look at here. Sec theta minus tan theta into bracket sec theta plus tan theta. What we are going to get? Yes, sec square theta minus tan square theta. Easy? Now you have already learned trigonometric identity 1 plus tan square theta is equal to sec square theta. If we rearrange the term, what we get? Sec square theta minus tan square theta is equal to 1. What we have derived here is sec square theta minus tan square theta. That means value of sec square theta minus tan square theta is equal to 1. Hence proved. Let's move on to the next problem. We have to prove sec theta plus tan theta into 1 minus sin theta is equal to cos theta. Let's take LHS first. We have taken LHS and simplified it. We get sec theta minus sec theta into sin theta plus tan theta minus tan theta into sin theta. How did we get this? Sec theta into 1, sec theta into minus sin theta, we get minus sec theta into sin theta. Tan theta into 1, tan theta into minus sin theta, minus tan theta into sin theta. We have already learned sec theta is equal to 1 upon cos theta and tan theta is equal to sin theta upon cos theta. Let's replace sec theta by 1 upon cos theta and tan theta by sin theta upon cos theta into this equation. We get 1 upon cos theta minus 1 upon cos theta into sin theta plus sin theta upon cos theta minus sin theta upon cos theta into sin theta. So these two sec theta got replaced by 1 upon cos theta and these two tan theta got replaced by sin theta upon cos theta. Simplifying it further, 1 upon cos theta minus sin theta into 1 is sin theta upon cos theta plus sin theta upon cos theta minus sin theta into sin theta, sin square theta upon cos theta. Now here we have minus sin theta upon cos theta and plus sin theta upon cos theta. So those two get cancelled out. We get 1 upon cos theta minus sin square theta upon cos theta. As you can see, the denominator is common, so we can simplify it as 1 minus sin square theta upon cos theta. Now let's use trigonometric identity sin square theta plus cos square theta is equal to 1. Simplifying it, we get cos square theta is equal to 1 minus sin square theta. We have numerator as 1 minus sin square theta. So let's replace that with cos square theta. What we get is cos square theta upon cos theta. So 1 cos theta gets cancelled out. What remains is cos theta in the numerator, which is right hand side. Let us solve the next problem. We have to prove sec square theta plus cosec square theta is equal to sec square theta into cosec square theta. As usual, we will take the LHS first. We have already learned two trigonometric identities. 1 plus tan square theta is equal to sec square theta and 1 plus cot square theta is equal to cosec square theta. Let's replace sec square theta and cosec square theta by these. What we get is LHS as 1 plus tan square theta plus 1 plus cot square theta. Now here 1 plus 1 becomes 2. So we get 2 plus tan square theta plus cot square theta. We have also seen sin theta upon cos theta is equal to tan theta, and cos theta upon sin theta is equal to cot theta. Replacing this into the equation, we get 2 plus sin square theta upon cos square theta. Pay attention, since this is a tan square theta, we have replaced it with sin square theta upon cos square theta plus cos square theta upon sin square theta. To do the addition, let's cross multiply by denominator. Sin square theta will multiply the sin square theta here, and cos square theta would multiply cos square theta here. What we will get is 2 plus sin raised to 4 theta plus cos raised to 4 theta, and at denominator we will get cos square theta into sin square theta. Now pay attention to this 2. This 2 can be written as 2 into 1, which is nothing but 2. Why we are considering it as 2 into 1? Let me explain. We have already learned sin square theta plus cos square theta is equal to 1. So this 1 can be replaced with sin square theta plus cos square theta. Let's do that. What we get is 2 into bracket sin square theta plus cos square theta plus sin raised to 4 theta plus cos raised to 4 theta divided by sin square theta into cos square theta. If you pay close attention to this, you will get some hint. Let me explain. Let's assume A as sin square theta and B as cos square theta. If we expand A plus B bracket square, we get A square plus 2AB plus B square. We have assumed A is equal to sin square theta and B is equal to cos square theta. So sin square theta plus cos square theta bracket square would be sin raised to 4 theta plus 2 sin square theta plus cos square theta plus cos square theta. If you look carefully, this is nothing but same. So we can replace it with sin square theta plus cos square theta bracket square. So we get sin square theta plus cos square theta bracket square upon sin square theta into cos square theta. We have already seen sin square theta plus cos square theta is equal to 1. So replacing this sin square theta plus cos square theta by 1, what we get? 1 raised to 2 upon sin square theta into cos square theta. Now we have also seen 1 upon sin theta is equal to cosec theta. So 1 upon sin square theta will become cosec square theta, and 1 upon cos theta is sec theta. So 1 upon cos square theta would become sec square theta. Hence we get cosec square theta into sec square theta, which is nothing but right hand side, hence proved. Moving on to the next, we have to prove cot square theta minus tan square theta is equal to cosec square theta minus sec square theta. As usual, let's take LHS first. I'm sure now by looking at LHS you must have guessed what we are going to do. Cot theta is nothing but cos theta upon sin theta, and tan theta is nothing but sin theta upon cos theta. Let's replace these values. We get cos square theta upon sin square theta minus sin square theta upon cos square theta. For doing subtraction, let's cross multiply. We get cos square theta into cos square theta is nothing but cos raised to 4 theta minus sin square theta into sin square theta is sin raised to 4 theta upon sin square theta into cos square theta. We have already seen so many times a square minus b square is equal to a plus b, a minus b. Assume a is equal to sin square theta, b is equal to cos square theta. Expand cos raised to 4 theta minus sin raised to 4 theta as cos square theta plus sin square theta into cos square theta minus sin square theta. Denominator remains as it is, sin square theta into cos square theta. Again, we have seen so many times previously, sin square theta plus cos square theta is equal to 1. So replacing this cos square theta plus sin square theta by 1, we get cos square theta minus sin square theta, which is remaining only, upon sin square theta upon cos square theta. Simplifying it, cos square theta upon sin square theta into cos square theta minus sin square theta upon sin square theta into cos square theta. Cos square theta gets cancelled out here, and sin square theta gets cancelled out here. So what remains is 1 upon sin square theta minus 1 upon cos square theta. I'm sure you must have visualized the answer, because 1 upon sin theta is nothing but cosec theta. So 1 upon sine square theta becomes cosec square theta. 1 upon cos theta is sec theta. 1 upon cos square theta becomes sec square theta. So we get cosec square theta minus sec square theta, which is nothing but RHS, hence proved. Moving on to the next, we have to prove tan raised to 4 theta plus tan square theta is equal to sec raised to 4 theta minus sec square theta. Pause the video here and try to solve it on your own. Let me give you a hint. Work on left hand side and use trigonometric identity 1 plus tan square theta is equal to sec square theta. We will provide the answer. However, try to solve it on your own first. LHS is tan raised to 4 theta plus tan square theta. Let's take out tan square theta common out of this. We get tan square theta into bracket 1 plus tan square theta. Now let's use 1 plus tan square theta is equal to sec square theta. We can replace this 1 plus tan square theta by this sec square theta. We get tan square theta into bracket sec square theta. Now again pay attention. 1 plus tan square theta is equal to sec square theta. So tan square theta is nothing but sec square theta minus 1. Now we can replace this tan square theta by sec square theta minus 1. We get sec square theta minus 1 into bracket sec square theta. Multiplying it, we get sec square theta into sec square theta, sec raised to 4 theta, minus sec square theta into 1, sec square theta, which is nothing but our RHS. Easy? Let's solve the next. We have to prove 1 upon 1 minus sine theta plus 1 upon 1 plus sine theta is equal to 2 sec square theta. Let's take LHS and simplify it. We will do addition, so we have to do cross multiplication for the denominators. 1 into 1 plus sine theta plus 1 into 1 minus sine theta upon 1 minus sine theta into bracket 1 plus sine theta. Now if you focus on denominator, we have applied so many times a square minus b square is equal to a plus b into bracket a minus b. Here a is 1 and b is sine theta. Applying this, we will be getting 1 square minus sine square theta into denominator. So what we get is 1 plus sine theta plus 1 minus sine theta upon 1 square minus sine square theta. Simplifying it, sine theta plus and minus gets cancelled out. We get 1 plus 1, 2 upon 1 square is 1 minus sine square theta as it is. We have seen previously sine square theta plus cos square theta is equal to 1. So cos square theta is equal to 1 minus sine square theta. So we can replace this 1 minus sine square theta by cos square theta. So we get 2 upon cos square theta. Now what is sec theta? It's 1 upon cos theta. So 1 upon cos square theta will become sec square theta. So we get 2 into sec square theta, which is nothing but RHS. Let's move on to the next one. We have to prove sec raised to 6 theta minus tan raised to 6 theta is equal to 1 plus 3 sec square theta into tan square theta. Let's take LHS. Sec raised to 6 theta minus tan 6 theta. We simplify it as sec square theta raised to 3 minus tan raised to 6 theta. Now we have already seen 1 plus tan theta is equal to sec theta. Instead of sec square theta, we get 1 plus tan square theta bracket cube minus tan raised to 6 theta. We have already seen in algebra in previous standards, a plus b bracket cube is equal to a cube plus 3a square b plus 3ab square plus b cube. Let's assume a as 1 and b as tan square theta and expand this 1 plus tan square theta raised to 3. We get 1 cube plus 3 into 1 square tan square theta plus 3 into 1 into tan square theta bracket square plus tan square theta cube. minus tan raised to 6 theta as it is. Now pay attention. The second term, that means tan square theta raised to 3 is nothing but tan raised to 6 theta, which gets cancelled out. Hence we get 1 raised to 3 nothing but 1 plus 3 into 1 square would be only 1. So 3 into tan square theta plus 3 into tan raised to 4 theta. Now from these two terms, let's take out 3 into tan square theta common. What we get? 1 as it is plus 3 into tan square theta common into bracket 1 plus tan square theta. We have already seen over here what is 1 plus tan square theta? Sec square theta. So let's just replace. We get 1 plus 3 tan square theta into sec square theta, which is nothing but our RHS. Let us solve the next. We have to prove tan cube theta minus 1 upon tan theta minus 1 is equal to sec square theta plus tan theta. I am giving you a hint. We will use a cube minus b cube is equal to a minus b into bracket a square plus ab plus b square. Assume a as tan theta and b is equal to 1. Pause this video and give it a thought. How can we solve this? Let us solve this. Let's take LHS. Tan cube theta minus 1 upon tan theta minus 1. As shown you in the hint, we can expand tan cube theta minus 1 considering a as tan theta and b as 1. So this would be tan theta minus 1 into bracket tan square theta plus tan theta into 1 plus 1 square theta. I have simplified it by showing what is a and what is b. A minus b, tan theta minus 1, a square tan square theta plus ab tan theta into 1 plus b square, 1 square. What we have used here is, we have taken the advantage of 1. Tan cube theta minus 1 can be considered as tan cube theta minus 1 cube. And that's how we are solving this. Divided by tan theta minus 1 as it is. Now tan theta minus 1 and tan theta minus 1 gets cancelled. What is remaining is tan square theta plus tan theta plus 1. Now 1 plus tan square theta is equal to sec square theta. You can see there is 1 and there is a tan square theta. So we can replace this 1 plus tan square theta by sec square theta. What we get is sec square theta plus tan theta, which is RHS. For next problem, I will give you hints. You try to solve it on your own. Otherwise, solution would be provided. But I highly recommend try to solve it on your own. Problem is, we have to prove tan theta upon sec theta plus 1 is equal to sec theta minus 1 upon tan theta. First hint is, take left hand side, replace tan theta by sin theta upon cos theta for numerator and sec theta by 1 upon cos theta for denominator. Solve it further. Then multiply numerator and denominator by 1 minus cos theta. Simplify it further. Then divide numerator and denominator by cos theta. Simplify it further. Cross check your answer here. Let's solve next. We have to prove sin theta minus cos theta plus 1 upon sin theta plus cos theta minus 1 is equal to 1 upon sec theta minus tan theta. This is a bit complex problem, so please pay attention. We will make it simple for you to understand, but you have to pay attention to each and every step. Let's start. Let's take RHS first, which is 1 upon sec theta minus tan theta. We already know sec theta is equal to 1 upon cos theta and tan theta is equal to sin theta upon cos theta. We get 1 upon cos theta minus sin theta upon cos theta. As you can see now, the denominator is common, so we can do the subtraction easily. What we get is 1 upon 1 minus sin theta upon cos theta. Simplifying it further, which is cos theta upon 1 minus sin theta. This cos theta has gone into the numerator, and that's why cos theta upon 1 minus sin theta. Let's multiply both numerator and denominator by 1 plus sin theta, which is conjugate of 1 minus sin theta. Let's do that. Cos theta upon 1 minus sin theta into 1 plus sin theta upon 1 minus sin theta. Now we can use a square minus b square is equal to a plus b, a minus b for the denominator. 1 minus sin theta, 1 plus sin theta. We will be having 1 square minus sin square theta. So what we get total is cos theta into 1 plus sin theta, numerator as it is, divided by, in denominator, we get 1 square, that is nothing but 1, minus sin square theta. We have already used this several times. Sin square theta plus cos square theta is equal to 1. So cos square theta is equal to 1 minus sin square theta. Let's replace this 1 minus sin square theta by cos square theta. What we get is cos theta into 1 plus sin theta upon cos square theta. Now 1 cos theta from numerator and 1 cos theta from the denominator gets cancelled. So what we get is 1 plus sin theta upon cos theta. Now this is our RHS. That means we have proved that up till now 1 upon sec theta minus tan theta, which was our original RHS, is equal to 1 plus sin theta upon cos theta, which is derived RHS. From our original problem, sin theta minus cos theta plus 1 upon sin theta plus cos theta minus 1 is equal to 1 plus sin theta upon cos theta. Let's send this cos theta to LHS, so it will multiply sin theta minus cos theta plus 1, and send this sin theta plus cos theta minus 1 to RHS, which will multiply the numerator 1 plus sin theta. So what we will have is sin theta minus cos theta plus 1 into cos theta is equal to 1 plus sin theta into sin theta plus cos theta minus 1. Let's now solve LHS and RHS separately. Let's first simplify LHS. Cos theta multiplied by sin theta, so we get sin theta into cos theta. Cos theta into minus cos theta, we get minus cos square theta. Cos theta into 1, we get cos theta. Rearranging the term, sin theta into cos theta plus cos theta minus cos square theta. We have just brought this cos theta over here and send this cos square theta at the end. That's all. Let's simplify RHS. 1 into sin theta plus cos theta minus 1. It remains same. So it remains sin theta plus cos theta minus 1 as it is. Now sin theta into sin theta, we get sin square theta. Sin theta into cos theta, sin theta into cos theta, sin theta into minus 1, we get minus sin theta. Plus sin theta and minus sin theta get cancelled. And we have already learned sin square theta plus cos square theta is equal to 1. Simplifying, we get sin square theta is equal to 1 minus cos square theta. We have sin square theta here, so we can replace it with 1 minus cos square theta. Let's do that. What we get is cos theta as it is, minus 1 as it is. Now this sin square theta becomes 1 minus cos square theta. So 1 minus cos square theta plus sin theta into cos theta as it is. This minus 1 and plus 1 gets cancelled out. So we get cos theta minus cos square theta plus sin theta into cos theta. Simply rearranging the term, this sin theta into cos theta is brought first, then plus cos theta, and then minus cos square theta is sent to end. Now did you notice LHS is sin theta into cos theta plus cos theta minus cos square theta, and here RHS sin theta into cos theta plus cos theta minus cos square theta. They both are same. So LHS is equal to RHS, and that's why we have proved sin theta minus cos theta plus 1 upon sin theta plus cos theta minus 1 is equal to 1 upon sec theta minus tan theta. You need to solve this problem on your own multiple times so that you get confident about solving it if it comes into the exam. Please subscribe to our channel and hit the like button. Your support will encourage us to make more with such videos on mathematics. Thank you.